students, in the previous section we have seen what is the lift force and the drag force and method to derive how lift force and drag force comes into existence. Now we are going to apply those formulas and concept to solve real life problems on lift and drag. So we have a problem over here, that is a man weighing 90 kg descends down to a ground from an aeroplane with the help of a parachute against the air. The velocity with which the parachute, which is in hemisphere in shape, comes at 20 meters per second. Find the diameter of the parachute assuming coefficient of drag is equals to 0.5 and the density is 1.25. So this is also a problem which we have seen, which was on drag in the previous sections. So there will be a parachute over here which is hemisphere in shape, and a man is attached to this parachute. Let us consider that as a box, and this is a parachute which is hemispherical in shape. Now this parachute will come down through various layers of the fluid. Now while it is coming down through the various layers of the fluid, there will be increase in the drag. Now this drag will be increased by the area of this entire hemisphere. So now if we can see over here, the weight is going downwards but the drag force will be in the upward direction. So in equilibrium, what will happen is summation of Fy will be equals to 0. The drag force will be equals to the weight of the entire part. So now let us equate this in this equation and let us solve this. Before that, we'll just write down the data which we know. Now what is given to us over here, that is the weight is equals to 90 kgf, that is 90 into 9.81. this is given to us as, this will be 882.9 Newton. Next is u is equals to 20 meters per second, that is the velocity of the fluid with which velocity of the air, or the velocity of the parachute rather, it is coming down. When the parachute is coming down, what happens is the body is moving but the air is at rest. So the effect of drag it will be same as the air is moving and the body is at rest. So velocity is given to us. Next part is the density of air, that is 1.25 kg per meter cube, and next part is given to us as the coefficient of drag, this is 0.5. So we know that we have to find the area of cross section. From area of cross section we'll get the diameter of that entire part. So we know that the drag force will be equals to the weight, and the drag force is also equals to rho, or first we'll write down coefficient of drag, rho a into u square upon 2. Out of these things we know the weight, we know CD, rho, u, we all know all these values. Then we can calculate area. Once we know the area, we can calculate the diameter of the hemisphere. So now let us calculate this part over here. So the force due to drag will be equals to 882.9 Newton. Why? Because summation of Fy will be 0 and force due to drag will be equals to the weight. Now if we substitute over here, we'll get this as equals to, let us write down separately, this will be equals to Fd is equals to 882.92 Newton. So Fd is equals to rho A CD U square by 2 is equals to 882.9 Newton. So if we substitute, that is 1.25, and area is pi by 4 d square. CD is 0.5. U is given to us as 20 meters per second divided by 2 is equals to 882.9 Newton. So on evaluation of this, we will get this as d square is equals to 8.9946. So D will be equals to 2.999 meters. So this will be the diameter which we will be calculating. So we have calculated what is the diameter over here. So I hope you have understood how we have seen a problem on parachute where the drag force which is upwards will be equals to the weight of the body which is going downwards. Thank you.